Hey everybody, wanted to tell you today about a concept called a reference angle. And I have a picture of an angle here. This is about 140 degrees perhaps. And suppose I wanted to know what sine of 140 is. You know, it's pretty easy. We live in a day of Google and calculators. We could simply type sine of 140 and get our answer. But before there were calculators around for everyone, people would have in the back of their textbooks tables like this that have all the different angles and all different sines and cosines and tangent values. And so you might have to look through it'd have to be a huge table if you wanted to know sine of 140. And frankly, textbooks didn't waste that much ink and paper on gigantic tables like that. It turns out if you want to know what sine of 140 is, you can find that by referring to a different angle. This angle, which is, let's see, 140 to 180, this would be a 40-degree angle. That would be the reference angle here. If you wanted to know what sine of 140 is, you could just look up sine of 40. And so that greatly reduced how much of a table that textbooks would have to print. Anyway, it's kind of an old-fashioned idea in that regard, but reference angles still have a really useful application when we're solving equations and all that sort of stuff too. So they're still worth knowing. So as I was saying, angles in any of the other quadrants, quadrant 2 or quadrant 3 or quadrant 4, have what's called a reference angle. That's what's drawn here. It's always measured to the closest x-axis. And so in our example just a moment ago, if this is 140 degrees, then to get to 180, there'd be 40 degrees left, and that would be its reference angle. Here's a quadrant 3 angle, and maybe it's close to, I don't know, I might call it 260 degrees. So that's beyond 180, and how much beyond 180 is what we would need. So 260 minus 180, that would be an 80-degree reference angle. Here's an example of an angle in quadrant 4, and so this looks like it might be 310 degrees or something like that. And so if we wanted to know what its reference angle is, we would have to subtract from 360 the 310 that we got here. And so 360 minus 310 is 50, and so this would have a reference angle of 50 degrees. And once again, the idea of reference angle is if I wanted to know what sine of 310 is, I could look up what sine of 50 is, and it would be kind of the same thing. We'll get into positives and negatives, a little bit of differences later on, but that's a reference angle. So let's look at a couple of quick examples of finding reference angle. To find the reference angle, first thing you ought to do is draw the angle. Make sure it's in the right quadrant. That's about all you really need. It doesn't have to be super perfect. So here's 320. I know it's more than 90, more than 180, more than 270, less than 360. So it's in quadrant 4 here. And what I need to know is how close to 360 is it? And so the reference angle for 320 is going to be 360 minus 320. Which would be a 40-degree angle. 140 degrees, that was actually the example we started off class with. So here it is drawn, and that is between 90 and 180. And what I want to know is how close to 180 is. And so I'm going to have to subtract 180 minus 140 to get a 40-degree reference angle. For negative 150, remember negative angles go backwards and around. So here's 90, and here would be negative 180. And so it's close to negative 180. I want to know how far away from negative 180 is it. And so I'm going to do a subtraction. And so 180 minus 150, just working with their absolute values here, because reference angles are always positive numbers, at least the way I think about them. They're always positive numbers. There's some disagreement with that amongst teachers, but I would say that negative 150 has a 30-degree reference angle. And 514, that's a big angle. It goes all the way around past 360, past 450, but not quite to 540. And so what I want to know is how far between 540 and 514 it is. And so I'll have to do a subtraction. 540 minus 514, what is that, 36 degrees? 26 degrees. Here's a couple of examples of trying to find reference angles when angles are measured in radians instead of degrees. Frankly, I think it's actually easier when things are measured in radians instead of degrees because you can simply count wedges, if you will. Here is 7 pi twelfths. Remember to draw 7 pi twelfths. You take a half plane and you cut it up into 12 equal pieces. And then you would go around and count 7 of them. And so there's 7 pi twelfths. The reference angle is how many more you have to go to get to the nearest x-axis. And so in this case, the nearest x-axis would be here at pi radians, or 180 degrees. And there's 1, 2, 3, 4, 5 of those wedges. And so the reference angle is simply 5 pi twelfths. For pi fourths, cut one wedge or one half plane up into 4 equal pieces that are drawn here, and then count backwards 3 to get negative 3 pi fourths. And what we want to know is how close we are to the nearest x-axis, and so this would be 1/4 of pi. For 11 pi eighths, again, we'll split a half plane up into 8 equal pieces. We'll count around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them. And I want to know how close I am to the nearest x-axis. That would be right here. That's 3 of these eighths away. So reference angle would be 3 pi over 8. And for 23 pi sixths, it's quite a ways around. It's almost 2 times around. What I want to know is how close to this nearest x-axis I am. And so that looks like 1 of these wedges, which are sixths. So it must be 1/6 of pi, or simply pi over 6. Now we're going to answer some questions, and that is simply to find, if you're given one angle, what are the angles in the other quadrant that have that same reference angle? So let's start with a 20-degree angle. Here is a picture of a 20-degree angle. And what I want to know is what are the angles here measured in green? So the reference angle for 20 degrees is kind of boring. It just is 20 degrees. But what I want to know are what are these other angles? Now the goal is to figure out what each of the other angles are. So we know this one is 20 degrees. But what's this? And you use the reference angle and the either 180 degrees or 360 degrees, and you either add or subtract the reference angle. So this is 20 degrees short of 180, and so 180 minus 20 would be 160 degrees. Down here, this is 20 degrees more than 180, and so 180 plus 20 is 200. And in quadrant 4, the reference angle is 20. That means this green angle is 20 short of a full circle, 360. So 360 minus 20 would be 340 degrees. Let's try another example with 150 degrees. So 150 degrees, that's this angle right here. And so that is almost 180. It's definitely a quadrant 2 angle. Let's find its reference angle first. So how far away from 180 is that? That is 180 minus 150 is a 30-degree reference angle. And so now my goal is to find the other angles that have that same reference angle. So we were told a quadrant 2 angle, so we can fill that in right now. That's 150. And let's see if we can, well, we know quadrant 1 because that's the reference angle itself. So we can fill that in. That's 30 degrees. So this angle down here is going to be our reference angle more than 180. So 180 plus 30 is 210 degrees. And here in quadrant 4, that is 30 degrees short of a full circle. So 30 degrees less than 360. 360 minus 30 is 330. If you'd like, now might be a good time for you to hit pause and see if you can find all the other angles that have the same reference angle as 220 and 318. We should be able to do the exact same sort of question when angles are measured in radians instead of degrees. And so here is an angle, 7 pi sixths. Its reference angle would be, let's see, each of these little wedges are a sixth of pi. And so its reference angle must be 1/6 of pi. And if we wanted to then look at each of these other angles in the other quadrants that have the same reference angle, we can start to fill in some things here. We know this one was given to us was 7 pi sixths. And up here, this would be one less than this. It's kind of important to know what is all the way across. So that is 6 pi sixths. So if I subtract one of those away, that would give me 5 pi sixths. In quadrant 1, the angle is simply the reference angle. So that would be 1 pi sixths. And down here, quadrant 4, this angle is one less than a full circle. And so a full circle would be 1, 2, 3, 4, 5, 6, 7, 8, 12 pi sixths. And so one short of that would be 11 pi sixths. I would encourage you to try to find the rest of them a second and see how you did. Hopefully you were able to find that the reference angle for this is pi thirds, and that gives us reference or angle in quadrant 1 is pi thirds, and this would be 2, then 3, 4 pi thirds down here, and 5 pi thirds. For the 7 pi tenths problem, the reference angle was 3 tenths, and that gives us 3 tenths in quadrant 1. 7 here, 8, 9, 10, 11, 12, 13 pi tenths down here, 14, 15, 16, 17 pi tenths in quadrant 4. And then for the final problem, 24 pi sevenths, that has a reference angle of 3/7 of pi. And so our first quadrant angle is 3/7 pi, and then 4/7 pi, 5, 6, 7, 8, 9, 10/7 pi down here, and 11/7 pi in quadrant 4. So I hope the reference angles will serve you well, especially when we start solving some equations in a week or so. And so let me know if you have any questions, and I'll be glad to help. See ya.